One really common three-dimensional shape that we haven't talked about yet in Chapter 11, and that is the sphere. So today you're going to learn how to calculate both the surface area and the volume for spheres. The technical definition of a sphere is the set of all points in space equidistant from a given point. You're used to thinking about spheres in terms of just being a ball shape, but really the technical definition of a sphere is the same thing as one of those baubles you find at craft stores. These bauble, the ends of the yarn represent the sets of all points in space equidistant from the center, because all the yarn's the same length. So that's really the technical definition of the sphere, the collection of all the points, the radius, distance, out in all directions from the center. There's a couple other terms you need to be familiar with. Hemisphere means half of a sphere, and a great circle is the largest possible cross-section of a sphere. So, for example, this dotted line here, that's the largest possible cross-section. I'd get smaller circles if I took cross-sections anywhere else. That's a great circle. To calculate the surface area of a sphere, you would use this equation, 4 pi r squared. Here's a quick visual representation of how it works. Notice how 4 pi r squared is really 4 times pi r squared, area of the circle. 4 circle areas. Now, think of the way a baseball or a softball is constructed. Think about what that would look like unraveled. Do you see how that's 4 circles to cover the outside of your ball? In other words, it's 4 pi r squareds of area. So I would start by writing down your surface area formula for spheres, 4 pi r squared, and then look at your picture and find your radius, find your r halfway across the center of the sphere. Quick reminder about the importance of the order of operations. Remember PEMDAS, please excuse my dear Aunt Sally. It's really important that you do the exponent part of simplifying before you do the multiplying. So make sure you do 5 squared and get 25 and then times by the 4. And then you just move the pi to the end. You're going to, unless it's a word problem, generally leave your answers in terms of pi. And because surface area is a type of area, your units are squared. Your final answer is 100 pi square centimeters. Notice how occasionally they'll give you the diameter of the sphere and you'll have to cut it in half to get the radius first and then plug it in. Pause here and solve question 2 on your own. Go ahead and check your answer for question 2. You should get 9 pi square yards. Now, sometimes you'll get a word problem, such as this one. What is the surface area of a ball with a circumference of about 25 inches? So whenever I get a word problem, I like to summarize what they're telling me and what they're asking me to solve for. They're telling me their circumference is 25, and they're asking me for surface area. Since they're telling me circumference, I'm actually going to start with my circumference formula. C equals 2 pi r. And in that formula, I could say, well, the C, I know that's 25. Now, if we use this formula, 25 equals 2 pi r, we can solve for r, and once we know what the radius is, then we could plug it into our surface area formula. So circle the r and think about what you would have to do to get it by itself. Oh, you'd have to divide by 2 and divide by pi to cross both of them out. Now, a really quick note about how you're putting this in your calculator. Make sure when you type it in your calculator, you type 25 divided by parentheses 2 pi end parentheses, because if you don't have parentheses, the calculator thinks you're only dividing by 2 and then that you're multiplying by pi. It gets confused very easily. So divide by parentheses 2 pi so it knows both those things go under the fraction, and then you should get the correct answer, which is really, really close to a radius of 4. So we have our radius. Now that we have our radius, we can actually answer what they're asking us for, surface area. So take that radius and plug it into your surface area formula. Notice how with some of the word problems, instead of saying leave your answer in terms of pi, they'll say something like round to the nearest whole number. That implies they actually want you to, instead of leaving your answer as 64 pi, actually say, well, pi is really 3.14, so do 64 times 3.14 and round to the nearest whole number. Sometimes they'll give you a word problem where they actually start off by telling you what the surface area is. So our word problem summary here is that the surface area of a world globe is about 1,018, so SA equals 1,018, and they're asking for diameter. So whatever they're telling me the answer for, I'll start with that formula. So we're starting with our surface area formula, SA equals 4 pi r squared, but we're saying the surface area is really 1,018. And then you're going to circle r squared and get it by itself so that we can solve for r. Like the last problem here, you're dividing by both a 4 and a pi. So when you put it in your calculator, make sure you're typing divided by parentheses, 4 pi and parentheses, so it knows both those things go under the fraction bar, not just the 4. Now, when you divide 1,018 by 4 pi, you get something pretty close to 81. And then to get rid of the square on the r, you would have to square root both sides. And when you square root 81, you would get 9. So now you know the radius is 9. Whenever I think I'm done with a word problem, I go back and read the question or my summary of the question again. Oh, they're not asking for radius, so I'm not done. They're asking for diameter. Radius is half of diameter, so I just take my radius and double it to get the diameter all the way across the circle. So the diameter is roughly 18 inches long. All right, so that's everything you need to know about surface area. Let's talk about calculating the volume of a sphere. How much space is inside of that three-dimensional shape? Your formula for volume of a sphere is 4 pi r cubed all over 3. Notice how it's cubed, not squared, like surface area. Notice how many of your volume formulas you've learned this chapter actually have an over 3 element, including your volume of a cone and a volume of a pyramid, and now volume of a sphere. It's a common pattern for volume formulas, and you'll learn more about why if you take a calculus in a couple years. So here we have that sphere with a radius of 12, so we plug that in for r in our 4 pi r cubed all over 3 formula for volume. Now, as you recall, order of operations, we have to do the exponents before we do the rest of the problem. So we have to figure out what 12 to the power of 3 is. Now, depending on your type of calculator, you either have a button that looks like this, like an x to the power of y button, or you have a caret button, like pointing up. So to figure out what 12 to the power of 3 is, you first type 12, and then you hit whichever version of that button you have, and then the power of 3 is what you type next. Press enter. And you should get that 12 to the power of 3 is about 1,728. And now you could simplify the rest. You temporarily ignore the pi. You do 1,728 times 4 divided by 3 and just put the pi at the end of your answer. Notice how because we are now calculating volume, your answers are in inches cubed. Pause here and try question 6 on your own. Go ahead and check your answer on number 6. Number 7. The volume of a sphere is 2,200 yards. What is the surface area of the sphere? So when you summarize your word problem, you know the volume, and they're asking for surface area. Whatever you already know the answer for, you're going to start with that equation. So we're going to start with our formula for volume. Now our goal is to solve for radius, to get r by itself. So to do that, we're going to it's a little bit like peeling an onion. We're going to slowly peel off each layer of numbers around the r cubed until it's alone. The outermost layer is over 3, so let's cancel that out first. The opposite of dividing by 3 is multiplying both sides by 3. And then you continue peeling off the other numbers surrounding the r cubed. So now you can cancel out the 4 and the pi by dividing by 4 pi. And this is where it gets a little bit odd because you need to now learn how to cancel out an r to the power of 3. Now the opposite of r cubed is a cube root, kind of like how the opposite of x squared is a square root. So a cube root is just a radical with a little 3 here. So to get r by itself, you're going to have to cube root both sides of the formula. Now here's how you cube root on your calculator. You type the sort of root it is first, the 3, to show that's a cube root. And then you hit the second or shift button. Some of your calculators say shift instead. And then after that, above the caret symbol, or for some of you above the x to the power of y symbol, there is in small print an x radical, an x root symbol. Type that. And then what should show up on your calculator is, it should look kind of like this, a 3 root symbol. And then you type the number you want to cube root, 525.2. A couple of you have calculators where it's a lot more straightforward. You literally have a cube root button, but not too many of your calculators have that. But if you have that, lucky you. So type that in and you should get a radius of around 8.1. If you're having trouble finding it on your calculator, let me know. And Schoology message me and I can help you figure it out. Now that you have a radius, go back and read what they're asking for. Oh, they're asking for surface area. So look at your formula for surface area from the front of your notes and plug in 8.1 for radius. And it's a word problem, so it's probably safer not to leave it in terms of pi, because most word problems they want it actually multiplied by 3.14 instead. And like last, you could round it to the nearest whole number. Great job today, guys. Don't forget to turn in a picture of your notes on Schoology.